Okay, so final question in the group 7 element section. This is question 4. This one again about the halogens, and it's asking us to describe the electronic structure of the halogens and how it changes down group 7. Now, as we've already looked at, really, the primary issue, primary characteristic of a group 7 element is the fact that it has 7 electrons in its outer shell. So if we draw fluorine first of all, fluorine has 2 shells. The first shell, as always, has 2 electrons in it. The second shell, or the outer shell for fluorine, then has 7 electrons in the outer shell. Now this is the same then for all of the elements underneath fluorine as well. So if we go chlorine underneath, then chlorine has exactly the same scenario, but this time has 1 extra shell, but it again still has 7 electrons in the outer shell. The only difference is it now has an extra inner shell because it's got more electrons and therefore requires more shells in order for those electrons to be occupied. But characteristically, everything down group 7 has 7 electrons in its outer shell. The difference is the size increases as we go down group 7 due to the presence of more and more shells as we go down. So if we then go into question 2, we are told that hydrogen reacts explosively with fluorine. That's because it's a very small atom and the electron is pulled very easily into its outer shell. However, it's asking us to predict and explain how astatine might do so with hydrogen and explain how it might react. Now, the first issue is how it might react. It's basically going to react very slowly. It's not going to be explosive because astatine is fundamentally much less reactive because the reactivity decreases down group 7 as we've already established. So it's going to react much slower and definitely not explosively as it does in the fluorine case. Now, what we also have to do is explain why. How can we make that prediction? We can make that prediction because fluorine and astatine, as we've already alluded to in question 1, both have 7 electrons in their outer shell. And if you have similar numbers of electrons in your outer shell, the chances are you're going to have a similar type of reaction. The only difference will be the vigor at which that reaction occurs. So because they've both got 7 electrons in their outer shell, then you can have a similar type of reaction in the ratio of elements that will combine, etc. So both in their outer shell. And then what we have to do is then just write a balanced equation. So we know that hydrogen is going to react with astatine, which is A2, and like fluorine, chlorine, bromine, etc., astatine exists as a diatomic molecule. Because it's in group 7, we know it's going to have a valency of 1 in the same way that fluorine would have had, and therefore we know we're going to have a HAT compound. And in order to balance up the equation, we need to have 2 HAT molecules to balance that out equation correctly.